Mohammad Farukh. He is an assistant professor in the Department of Electronics and Communication Engineering at National Institute of Technology, Warangal. He has been in his role at NIT Warangal since April 2018. He possesses a PhD and contributes both in teaching and research in the field of electronics and communication, and he is involved in several laboratory and theory courses, notably in digital signal processing and electronic instrumentation laboratories. To his credits, he has published many papers in reputed journals and conferences. He receives regular acknowledgement in institute reports and directories for teaching, administrative, and innovation center responsibilities. We welcome you, sir.
Thank
Sir?
you. Thank you.
Thank you.
Thank you. My screen is visible?
Yes, sir, it's visible, sir.
Thank you. So, thank you for my kind introduction, and thank you for inviting me for this talk. So, related
Welcome,
to so related to this talk, we are going to discuss about explainable AI, and which is the part of artificial intelligence, and also we'll discuss what are the various applications towards in the field of medical imaging, healthcare, and other part of the applications. So we will have the content point of view. We'll discuss how AI and machine learning and deep learning will correlate with respect to explainable AI, and later on we'll discuss various historical aspects of artificial intelligence. We'll see the explainable AI principles and working techniques, and how practically we can implement, and what are the applications of explainable AI will be there, and we'll see various applications towards the healthcare, medical imaging, computer vision. If the time will permit, we'll try to discuss certain case studies also, and finally we'll we are going to conclude and we'll see certain future directions also. So we are in the field of artificial intelligence. So we know that what is the importance of artificial intelligence related to AI. The concept is very important because we are going to enable the machines to learn from data. So basically, we are in the field of data science, and there every day the data requirement and data from the various sources are increasing day by day. So we are going to utilize artificial intelligence, and this AI will be enabled to the machine, and machine will be able to take the decisions with the help of data. So particularly when we'll increase the data, and this data will become big data, and then there are many computational requirement will increase. So complexity of the system will increase. So basically AI will help to automate complex tasks and with the help of low latency and real-time processing with respect to speed and precision. And now today's in the current trends, we can see AI has revolutionized the various industry, agriculture, healthcare, finance, and education. So we can observe that various impact will be there, and that impact will reshape how we are living now and how we can work in the different environment, and how we can make our system more and more smarter. So smart technology, which has improved lot in today's trend related to AI, help lot to speed up the particular task in terms of automated applications, as well as it will provide the various applications toward the medical field, finance, and education. So we can see that once AI is required, what is the purpose of AI? That means when we are developing the program with respect to in AI aspect, we can get the data, we can sense, and we can provide the reasoning, and we can act, and particularly based on the technology we can adapt. So machine learning is a subset of AI. Under that, various algorithms are responsible whose performance improve as they are exposed to more about data over the time. That means if you are moving towards the direction of machine learning, that means we want to design a system. That system will will act like a human, and under that like capability of the particular programming concept, which will improve by the experience. That means machine learning is the particular aspects in terms of AI where we are exposing on more data over the time, and we are going to just develop a automated system which will take the which will provide the decisions. So under the decision, the various algorithms which will improve the performance over the time without being explicitly programmed. And in machine learning, there would be more complex structure would be created through the artificial neural network. Later on, it would be extended to convolutional neural network. The concept of the deep learning is a subset of machine learning. Under that, we have the multi-layer neural network structure. By that way, we are able to learn vast amount of data, and the complete automation will take place because the feature extraction which were taking in earlier machine learning algorithms, it was applied as a particularly hello yes, उनको बोलो इंटरनेट नहीं आ रहा, just tell them.
Farukh sir, it is YouTube live, sir.
Oh, okay. You call me after that. I'm in session. So when we'll see the particular deep learning part here in machine learning system, which we have seen that we want to mimic the particular human, and where we are going to expose more amount data. Once data will increase, we are going to create a multi-layer structure with the knowledge of artificial neural network. And that is very important because we are going to learn from vast amount of data. So this is the complete paradigms of AI, machine learning and deep learning. So related to machine learning, already that we have seen, it's a branch of artificial intelligence which allow the computers to learn from data without being explicitly programming. That means it will improve the performance over the time by the experience, and the system will gain the knowledge and acquire the knowledge which will be able to solve the problem with respect to machine learning. So in machine learning, various algorithms are there. That means which will identify various patterns, which will make the decisions, which will provide the various predictions. So basically it will provide the automatically, that means system will improve automatically and it's get more data. So various applications we can observe under the machine learning. Under the machine learning, there are various learning method would be there, like with respect to characteristics of data. That means we can observe if data would be available in the label format. That means we can solve with the help of supervised learning. If the data won't be available with label, that means without label data can be solved by unsupervised learning. And one more method would be there, like where we can apply hidden trial. By that way we can improve the performance of the system. That is reinforcement learning. So these are the different learning method would be there in machine learning system. And application point of view, we can get it like spam of the filter. We can separate the which mail will go to the spam, which mail will go to the inbox, as well as various recommendation system, like recommendations of the human behavior or whatever the customer behavior. Based on that, Amazon, Flipkart, they are going to recommend the product. Likewise, we have self-driving car. Under the self-driving car, the system which will be able to get the data from the road, and the data will be extracted and will continuously drive the car with the mechanism of self-driving system. In that case, the data will be collected from various sensors in terms of vision sensors, in terms of lidar sensors, and which will be able to provide the solutions for self-driving car. Same in the machine learning will be extended by using of deep concept of deep learning. It's also branch of artificial intelligence. Under that, we are going to enable the machines which will learn from large amount of data. That means we are able to learn from large amount of data. It uses the neural network which consists of many layers, and we are going to identify the patterns and we'll get the more effective predictions, because when we will talk about machine learning system, there is a procedure when we are going to extract the feature, then feature selection, then going to classify. But in terms of deep learning, the concept of automated feature extractions, which will be extracted through the representation learning. So neural network consists of multiple layers. At multiple layers, there are multiple neurons would be there, and there the procedure automatically they may able to extract the feature, they may able to find out the patterns and will provide the prediction. So same the application self-driving car or various chatbots we are using, or various medical image analysis related to various imaging applications like brain tumor detections, or particularly in terms of Alzheimer detections, or various other idea related to medical imaging field or recommended system. Same way we can improve the performance of earlier recommended system in terms of agriculture recommendations or customer behavior with respect to various outcome are available. Now we'll see, when we have observed that last 25 years how the AI has grown. So related to it, we'll see the history of AI, what are the historical aspects are there. So in 80s and 90s, during that time, we were using the rule-based expert system. Then slowly the rise of machine learning started. So we have developed many machine learning techniques related to decentralized classifiers, SVM. So it was shifted to data-driven model, and also there are certain interpretability concepts are still remain, but complexity has increased. So initially, AI design were transparent and easily explained, but it was solved by using of the various rule-based technique. But this technique was limited as were having the scalability problem and flexibility problem. So rise of the machine learning has improved by the deep learning concept. So deep learning concept has proposed the powerful concept like a black box model. Under that, neural network, convolution neural network, or recurrent neural network has been implemented. It has been provided. It's a huge amount of the handling of the data as well as improved the accuracy. But still, interpretability was having the question mark in terms of low. That's why there is a other concept has been started like exponential AI, that is the growing demand of trust, requirement of fairness and accountability. So development tools like Lime, Shape and silencing maps has explained the particular complex model. So in the same direction, if you see what is the particular development of AI from the past almost 75 years, so related to 40s to 60, where the foundation of AI was established. In that, first AI neuron was conceptualized, and 1950 they introduced the Turing machine. So Turing has experimented the machine, which was the starting of artificial intelligence. The same duration after 10 to 15 years, the 1670s, there is a birth of Lisa simulating human conversation. So during the first expert system was implemented, that is the potential of AI. After AI was implemented, winter and expert system, then revival and emergence of machine learning. So 90s, the witness of IBM Deep Blue defending the particular chess champion Gary Kasparov Loom project, that is the generative AI foundation. 2000 onwards, we have seen that particular the whatever the generative AI the concept was required, that is propelled by deep learning into the limelight, and the AI was relentless growth and innovation. So from foundation point of view, when we have observed that rise of AI that marked during the 2010, the AI milestone including pioneering work in image recognition, image processing, natural language processing, that was the birth of generative adversarial network in 2014, that was followed by the OpenAI in 2015. More like 2020 onwards, we have seen that generative AI reaches the new origin because OpenAI, ChatGPT 3 and Dell E 2023, they welcome the advanced tool like ChatGPT 4 and Google Bard and Gemini along with the Microsoft Bing AI. So this is the particular historical point of view AI. We have seen that. Now what is the reason why we have observed that the rise of other architecture, other technology has been established? So we can observe here the rise of explainable AI, because the AI system already by increasing more number of data became more complex, and it is widely used because especially where certain sensitive area would be there, like healthcare or finance. This is the sensitive area because we should clear that understanding how AI will provide the decision. It is very crucial. So explainable AI emerged to make AI model more transparent. So it has provided more transparency and more interpretability related to helping user, because user has to trust on AI. And also there is a possibility where the particular technology will not be able to satisfy with respect to that outcome. So that means verify whatever the AI decisions are there. So we have to help to user about the trust and verify the AI decision. So that's the reason the shift address ethical concerns. So ethical concern has become the more crucial role here to identify various other part of explainable AI and explainable AI. So they reduce the bias and they have ensured that accountability in various AI applications. So these are the reason has motivated to use of explainable AI. Now normally what we have understood through the artificial intelligence. So basically in artificial intelligence we are having the data. So mostly we are categorizing the data into three categories. We are using data particularly for training as well as testing and validation. So related to that, whatever the machine learning and deep learning concept we have implemented, by that way we are going to train to the machines with the help of characteristics of data. If data would be there in terms of label or without label, or with where we want to use different other techniques. So whatever the learn function will be there, that functions will provide the decision and it will recommend certain output to the user. So what is the like requirement would be there? So like, why did you do that? Why not something else? Like that, certain answers need to be asked to the user. So that user will go back to the task and let learn function has to modify. So here that explanation are very important, because when we have trained the model, we don't know how to handle the data and what are the requirement to provide the data condition as per the decision or recommendation. So that questions was supposed to be not informed to the learn function. So before that, what we will do, we need to inform the explainable model. We have developed the wide range of new or modified techniques to produce more explainable models, or we can explain the complete depth about the model. So after that, explainable interface, which will integrate the human computer interaction strategy or principles. That principle will provide the effective explanation. So it will return back and will give the feedback. So like that, we whatever the questions was there, like why did you do that? So I understand why, I understand why not. I know when you get success, like that, the all answer has been clearly explained here by explainable AI model. So in terms of explainable AI, we'll see that what is the explainable AI. So here it referred to set of process. That means there are certain set of methods are there which allow the human users, which we can require to understand and trust the decision making. So whatever the model which we have implemented, we are not knowing that what is the requirement would be there. That means whether it is whatever the model which we have implemented, whatever the process we have implemented, that model which will give the idea whether it's a human are able to manage or how human will understand, and there is a trust condition would be there or not. So based on that, all these condition will be managed by AI model only. So what is the purpose of the explainable AI? We need to improve the transparency. We have to provide accountability and complete fairness where we are using AI driven system. So we should clearly provide the explanation how AI model generated and how AI model will provide the predictions, whether correct prediction will be provided or not, and what are the clear explanation of the input and whatever the outcome would be there, that will be given based on the decision also would be clearly explained. That is the role of explainable AI. So why explainable AI matters? As I said already, the transparency is very important. When we have developed the model, there are certain questions was not supposed to be answered by the model. So in that case, it should be very clearly give the model should answer whatever the question will be asked. So traditional machine learning model, it was the black box. We were not able to knowing that how they arrive at that prediction. That means why output has arrived, why the 98% accuracy has been arrived, and what are the reasons are that certain question was not supposed to be managed by the model. So trust and reliability is another factor. So because we have not clearly explained the model, we may have difficulty to provide the trust. So that accountability was not clearly explained there. So especially when critical applications like healthcare domain, where we are sending the data, whether we can believe that on the data or not, why the data is providing that much results, all this thing was not clearly given. So it is clearly and lacking of the explanation of the model, and it will be difficult on trust and reliability on them related to specific for finance work, legal decisions, or healthcare application. And verification also very important, because once we have detected certain output, whether correctly verified or not, so without interpretability, it's a very challenging task to verify the behavior or modify the particular model or detect the errors or ensure that whether ethically it's correct or fair or not. And adoption and usability, because explainable AI will help to build user confidence, will help to user to encourage the broader adoptions, and also it's responsible to use all new AI technologies. That is the major important aspect when we are using the explainable AI. So here, how we have to manage the explainable AI? The first thing is we have to understand the model first. So justify, explain to justify first, and also we need to apply the how to control, the explain how to control, and also explain to discover. That means whatever the science and research behind the model which we have discovered the new things. So we have to identify and we should explain how it has been discovered, what are the reasons it has been discovered, and also if there is a possibility would be there for improvement, we need to explain what way we can improve it. So explain to improve. So all these question need to be clearly identified with the help of explainable AI. So explainable AI will explain to justify, clearly justify the what is the condition of model, explain for control, explain to discover. So all these reasons are very important here. So similar way, when we'll see that what are the basic principles are available related to explainable AI. So in terms of explainable AI, when we'll see that it should be very transparent, that is the major principle of the explainable AI. So it should reveal that which factor influence the prediction. That means suppose if you are having data and you have improved the particular performance measure, so we should know that at why this factors, what factors are responsible to change that predictions, and they have influenced the prediction. So we have to help to build the trust, and also we have to offer useful insight across the application. And another factor is interpretability, because explainable AI, whatever the part will be there, so in that case that should provide easy to understand and making the model decision very clear. So if the model has identified or provide the result, it should provide a decision very clear and it should be useful for that. Or unlike traditional black box model, it was not able to provide the clear whether decision has correctly arrived or not and useful or not. And accountability, because explainable AI should support ethical condition, regulatory compliance, because in some medical reasons it should provide the ethical guideline, it should follow the ethical guideline, regulatory compliance are also needed, and ensuring that responsible and fair use of AI system. That is the major important part here. So how does explainable AI works? So we know that we refer that explainable AI methods and tools which help to human understand how AI system arrive at the decision. That means when we have received the decision, how it has arrived, how we have received the output. So for that case, it provides the all insights into whatever the underlying mechanisms are there or what are the factors are there. That factors are responsible those outcomes only. So basically, the process which we are going to develop, that means we have creating the that process, it must be transparent, it must be interpretable, that allow the user to trust on the AI technology. That means whenever we have received the output, we should trust whether it is correctly receiving or not. And also we have to verify the expected behavior of the technology. That means expected behavior of the AI models or potential models or debug models also. And also we need to meet whatever the regulatory or ethical requirement would be there. So we can say that whatever the explainable AI concepts are there, it include feature attribute. That means whatever the feature attributes are there, which will show that how much each feature contributed to prediction. That means correct features has correctly predicted or not, or irrelevant feature has contributed or not. That is the major concern we have to identify. And also we need to find out the specific predictions by the specific feature, development of inherently model, like whatever the different explainable AI models which we have seen that. So that means why it is important, as we already seen that trust and transparency important, model improvement is important, regulatory compliance are important, and human AI collaboration has motivated us to work in that domain only. So related to how does the explainable AI works, because the architecture of explainable AI, that can be thought of combination of these three components are there. That means whatever three components which will work together to provide transparency, to provide interpretability for various machine learning model. So architecture will provide the valuable insights, and also it will be benefited for the various domain and applications in terms of machine learning, in terms of deep learning, that will be more transparent, interpretable and trustworthy and fair. So where we have seen that, which we have implemented machine learning model. So machine learning model will be the more core component of explainable AI, because it will represent the underlying algorithms, it will represent the various techniques which are responsible to make it predictions and inference from the data. And this component is very important because there is a wide range of machine learning techniques like supervised, unsupervised, or reinforcement learning. We have discussed that. So various range of applications are there in terms of healthcare, medical imaging, natural language processing, or computer vision and retail. So explanation algorithms will be added here. That means that is very important, because explanation algorithm is also another component. So machine learning is one component, explanation algorithm another component of explainable AI, which is used to provide the insights and information about the factors which are very most relevant and will influence the model predictions only. So component that can be based on different applications, like different explainable AI approaches are there, like feature importance I said, feature attributions I said, visualizations are there, will provide the valuable insight with respect to working of machine learning model. So third aspect is interface, because interface is the main component of explainable AI, which is used to present insight and information generated by the explainable algorithm to human. That means whatever the explainable algorithm will be generated to human. So that component will be based on the wide range of technology, wide range of platforms like web applications, mobile applications, visualizations application, and also it will provide the user-friendly and intuitive way to access, interact with the whatever the information and insight generated by explainable AI systems are there. So now we'll see that how that AI systems are working, how explainable AI systems are working. We have data which is required for training, so that is considered as a training data. Here AI model has been implemented, so we have to validate the performance of AI model. Then we need to send that interpretability model. So that model will transfer to interpretability purpose. We have to manage trust, we have to manage casualty, we have to manage information loss, fairness, and transferability. And finally, it will help to the users, humans. By that, the completely we have explained each and every step and will be provided the outcome of the society or human. So explainable AI, various techniques are there which are very important. So that is the line, that is the popular explainable AI approach is there, that is used for local approximation of the model. That means locally we can approximate the model, also will provide the interpretability and explainable insights into the factor, and which is very important and influencing factor in the model predictions and model agnosticism. So that means it referred to apply the various properties. So here another property is line, which can give the explanation of any supervised learning model when we'll treat them as a black box separately. And the local explanations, that means we can say the line which will give the explanations that are locally factual. That means when we'll give the line local explanation. So here that explanation will provide the locally faithful within the surrounding or vicinity of the observation being explained only. So how line works? So we will take the sampling, will apply the surrogate data sets. So line will provide the faithful applications or explanation around the whatever the instance has been explained only. By default, we have 5,000 samples of the feature vector, and we have seen that normal distributed. Then we obtain the target variable. So target variable is a label for again 5,000 samples are there for predictions, while decision is trying to explain. After that, we have to select the features from your data set. So after obtaining of data set, each row according to how close are to be original sample. That means each row will provide whether this samples is correctly connected to original samples or not. So feature selection technique like ratio is obtained to the important feature only. So here explainable AI with respect to line, this is the instance of explanation. Here this is sample, new points will be around. So this is ML model, project the samples into this model. So this was not correct, this model has to correct here. We have received the output. So line with text data, this is the text data we have given. Like I love machine learning. So like that randomly we have removed the words in new samples, which will be provided the output of this local linear fitting one. Now we are taking our image data. The image data we have to segment the superpixel. We have to create the new samples, which is required for training on or off, and then we'll see the new samples into the model. So by that way we are projecting new sample to the model. So these are the three ways we are using the explainable AI in terms of this normal tabular data, text data, and image data. So related to that, another model shape works. How shape works? So shape is value calculation. So it calculates the contribution of each feature. Suppose there are 20 features are there. So what is the contribution of feature 1? What is the contribution of feature 2? By that way, we are taking the average of all impact across the possible combination of features, because it will be based on the shapely value from the game theory. This is very important. And then we are going to detect the fair feature attribution, because we are going to extract multiple features, but we don't know which feature is very important, which feature is not important, which feature is contributing, which feature is not contributing. So each feature is assigned the value that reflect how much is increasing and decreasing the model application. So we have assigned the value of certain feature, and by adding that feature, whether we are increasing the model performance, whether we are not increasing the model performance, it must be compared with respect to average predictions only. And finally, the consistency and interpretability explanation is very important. So because shape architecture explain the consistent, accurate, and interpretable making or overall model behavior. So here that explainable AI will consider into kernel shape, that is the line with shapely smoothing, or tree shape, that is the shapely estimate of trees, like the here predictions without X, that would be there. So that condition would be there, predictions without Z. And this deep shape, that is a shapely estimate the neural network. Here, that would be intimated the smoothing kernel only. So we are using the kernel which will be required for smoothing purpose. That will be done at that. So deep lift, that is an important feature. Deep learning is very important feature because this method explains the neural network predictions on its basic input. How? Because we are applying the back propagating contribution score from output to input layer. So output of each input factor, we are going to compute the back propagating contribution score. As we have seen that when we compare the activation of each neuron, that means with respect to reference activation and assign the contribution value based on the difference. So deep leaf reveal that dependency that other method may miss. So because it efficiently compute this scores only in a single backward pass through the network. For the next case, you will see that whatever the deep lift works will be there. We will compare the neuron activations. So first we'll take input to the reference as a baseline, and then we'll find out to the difference only. And back propagation, there is difference through the network to assign contribution. So this network will assign the contribution score for each input feature only. And we are going to separate the positive and negative contribution. That means once we have captured the detailed feature, we should tell which is related to positive feature, which is related to negative feature in the one backward pass. So related to another model, which is explainable AI method, deep shape. It is a combination of shape method with a deep lift method will be there. By that way, we are going to explain the predictions which is made by deep neural network. So we are going to compute the feature combination score because we have combined the model output with the crucial actual input to the reference input. That means we are combining that and using whatever the deep lift back propagation rules are there. So deep shape will provide the efficient local expressions, explanations about the approximations theory with the single backward pass. And also we can make the suitable for complex deep learning model. So here in terms of combined shape and deep lift, we both will merge by the condition of shapely and theory, because while deep lift will be utilized, they are using back propagation method efficiently, which is providing the attribute feature importance by using of deep neural network. So reference baseline comparison also very important because we have compared the model output for the given input against one or more reference input only. So one or more reference input which will give the more efficacy related to baseline. So we can measure that contribution of each feature and efficient back propagation. So in the deep lift network or architecture, whatever we are going to compute the approximation of shapely values in a single backward pass. So it should be completed in single backward pass because it's providing the fast and accurate low explanation only. So when we are using rules, it efficiently compute the approximation shapely values only. And when we are going to represent by fast and accurate local expression, we can get it. So here the deep shape neural network which you have created internal structure will give the input and predictions will be taken care. So first extraction from the architecture will be fed to the deep shape network, and then shape value per predictions would be identified. So now we'll see the practical implementation, how we can practically implement to explain AI. So we'll say that we've installed line. This will be installed import numpy as np matplot splt pand. So we have to load the data set using sklearn. Then you can just catch the data that we can fetch the data like California._housing. Same way we are going to separate the data, that means from the feature vector x and target variable y. So this is the data and this is feature. That feature vector will be combination of feature names only. So x train, x test, y train, y test. We are going to identify the data with training and the testing data with training. That means data during training time data would be labeled and testing data also would be labeled for validation. So this is the shape of the data would be calculated. We have to print them. So we have to apply the predictions model with extra tree regression. So SKLL library will be imported here. We need to compute the extra tree regression by using of random theory and X-train, Y-train. The data would be there. So we have to compute the score of model for test only and import the model for this model. So we have to import import lime tabular and conference, which will be created by using of this explanation object. So we have explainable line object by passing the training set and extraction features only. So we have to import the model for lime tabular explanation. So R2 score of the model test was computed here. This is the intercepting. This is the predictions local. It's the right. This is the prediction value would be computed 4.52. So related to 0.45 to 4.95 minimum maximum. This would be positive and negative calculation. So another architecture which we have seen that shape, which we have added this import shape or pandas numpy exhibits. So first we'll take the data set, load the data set in terms of data with target, X-train, X-train, Y-train, Y-train. You have to split the data. We are going to apply the exhibits classifier. Then we'll connect to the explainable AI. Then model will be implemented, and then we are going to apply the plot only. So shape value that will be computed by explainable AI, as well as we have to plot it shape value versus X and feature map only. So this is the output in terms of expected value of this expected and shape value for impact and model output. And this is the mean value. So for that mean value, average impact of model output only. So deep lift is another architecture which is practically implemented by using of the torch.nn, torch vision transformer, or matplot or numpy library. So immunized data set has been loaded here, transform them into that particular format. 60,000 images are there. Torch vision data set which we have taken through here only, and torch.utils.data. So we have just loaded data, and then we have to create the simple model only, class simple length, and by that way we are going to apply the forward only, and model will be evaluated. So this is original image from the immunized data set for character recognitions, which will be identified by deep lift attribution only. So once you'll see the explanation of AI, which is very crucial in healthcare and medical image, because where AI-driven decisions will provide the significant consequences for the patient. So because we'll get it the various significant consequences of patients, such as diagnosis, treatment, and patient outcome. So related to finance, the explainable AI is very essential in finance, because AI-driven decision will impact to the financial stability, will impact for security, as well as to compute the credit score, risk assessment, identification of risk assessment, and portfolio management also give the good opportunity here. So explainable AI, there are other applications like autonomous vehicle. It's a very crucial application, because AI-driven decision will have the significant consequences for safety, like navigation, obstacle detection, and emergency. And human resources, that is one of the applications which is crucial in healthcare application, where AI-driven decision have impact on like employee, such as recruitment, performance evaluation, and career development. This is the important part for human resources. So for real world applications of explainable AI, we have the healthcare, we have finance, we have autonomous vehicles, and we have the human resources. Already we have seen in healthcare, the explainable AI will improve the trust in diagnosis, because you will see the correct diagnosis has received or not, and also correct treatment has been received with respect to transparency and more decision making. Same way in finance also provide the clear explanations for credit score, for fraud detections and investment. And also autonomous vehicles, this explainable AI ensure that safety by explaining real-time decision has been taken or not, like for obstacle detections or for navigation. And also we have seen that human resources, which will promote the fair hiring. That means correct recruitment has been carried out or not with respect to that practices, or bias detection is there, or there is a transparency will be there or not for the recruitment and other factors. So related to explainable AI, we can see the application in healthcare. So what is the role of traditional AI in healthcare? That means what we have observed that traditionally what we have implemented. So AI is a key tool that can help to fix the big problems in healthcare, because we can manage the demand, we can optimize the resources, we can improve the quality care, we can improve the diagnostic accuracy. Also, we can tackle the tough challenges from many angles. So AI in healthcare is not about replacing the doctor, just only giving them smart tools and provide the smart techniques, and it will provide the fast response. So all these tools help things like diagnostic illness, finding new drugs, tailoring treatments, and making healthcare run smoother way. So we can see the applications of traditional AI healthcare like clinical disease support system, improvement in diagnostic or decision detections or disease detection, especially in medical imaging, and also provide the application in robotic assisted surgery, various new drug discovery and development, personalized medicine, treatment planning, remote monitoring, and also administrative efficiency and workflow improvement. All these are the application in traditionally level. If you see the clinical decision support system, so AI powered CDSS delivers faster and data driven diagnostic and treatment support for complex medical data. So if you are integrating of AI into clinical decision support system, it will improve the accuracy in decision detections or prognosis on personalized care pathway. So AI model which has improved the CDS and reduced the clinician workload and support decision making in high pressure scenarios like ICU and emergency care. So related to that, we can see patient data which is available, which will be given to AI model, and that will provide the clinical decision support system as the output, and then doctor will take the decision. So doctor will be able to take the decision based on this data and this CDS output only. And other aspects like diagnostic accuracy and disease detection, so we can improve the diagnostic accuracy. So AI will analyze the medical images, will get the complex data to identify the disease, to predict the disease and abnormalities, and also by that way we are going to improve the diagnostic accuracy when we are catching what human may miss. So early disease detection, because AI need to analyze the medical data. With respect to the data, it should be able to find out the sign of health problem, or often before symptoms appear, or enabling the earlier diagnostic only. So traditional AI, when we are going to use in medical imaging, that would be very helpful in terms of identification of the signs of disease, abnormality in scans like X-ray, MRI, CT scan. That might be very hard for human eye sometimes. So it can process and analyze the medical images. It will very in faster manner as compared to traditional methods only. And we can speed up the diagnosis part and also assisting radiologist only. So AI will contribute to more precise and consistent identification of health issues, and also leading to better patient care only. So we can just go through that how challenges and their solution would be applied. So there is a challenges risk to bias. So AI can learn from the data, leading to identify unfair or inaccurate patient advice. So basically how to overcome, we have to prioritize the data quality. We should ensure that AI has trained the diverse data, representative data, or unbiased data. Our integration complexity, when we are embedding AI into diverse or outdated or healthcare system, it's a significant technical hurdle. So we have to develop the interoperability standard, because commonly protocols like seamless data exchange and AI system integration with existing workflow. So bake off transparency and trust. So AI consists of the black box. It's a naturally, it's a hinders are there, clinical understanding and built the case from the users. It is a lack of the transparency and trust would be there. So crucially for embrace the explainable AI system, because we are going to develop the AI system that will provide the transparency, explain the reasoning, fostering trust and accountability. So in terms of any black box problem like opaque decision or eroding trust or adoption hurdles only. So black box, what is the nature will be there, has raised the significantly ethical, legal and safety concern. Without transparency, doctors struggle to trust whatever the AI devices or advice are there. Explainable condition of the patient would be there. Complications of the responsibility in high stack medical scenarios are there. So AI complex reasoning is often hidden and making it impossible for clinicians, which will be able to understand why specific diagnostic and treatment was recommended. So what is the explainable AI in healthcare? So mainly key features, key influences of explainable AI in healthcare is it identify the specific patient data. That means based on the age, lab report, features. It's very crucial for AI prediction. And also explain the decision. Once we have clarified why AI has made the particular recommendation, so explainable AI will provide and deal with the critical factors. It will lead to diagnosing and treatment services. And also it create the transparency. So basically transform the like a opaque black box, which will AI process the clear and human understandable explanation for clinician use only. So the reason for the need of explainable AI in healthcare is trust and patient safety, because explainable AI allow the professionals to understand and validate the AI reasoning, and also it's very crucial for informing the decisions and patient well-being. Accountability and compliance. So transparent AI model meet the ethical guideline, legal requirement, and establish the clear responsibility in health. And acceleration and adoptions, which will be very important for explainable AI, because explainable AI overcome major barrier of responsible integration and continuous improvement only. So we can get it when we'll see the black box AI input image, black box model predictions, and malignant stage will be there. So confusion of the black box model. I am in the malignant stage. Can I trust you? Input image, black box model with AI, explainable AI predictions. That is the malignant stage, because spread on this parts. So transparency of explainable AI has been identified. Why? So I see how you make a predictions. I can trust you because I understand only. So related to applications of explainable healthcare, transparent clinical decision support system, explainable discovery, personalized treatment and care justifications, and robust AI model auditing and enhancing the medical training. So medical training also we can improve it at this level. So according to that, that means when good external AI methods are there, AI application is specific, does not add any complexity, familiar to most users, cross-domain techniques, tools, and processes. It can be easily learned by using of this technique and easily applicable to other applications also. So when we see the transparency in clinical decision support system and imaging, so clear AI reasoning is very important, because explainable AI will provide AI diagnostic, AI treatment, recommendations, and particularly complex medical images are there like X-ray, MRI and all, and enable the verification. So clinician can understand why AI reached to conclusion, why AI reached to this much accuracy, and allow them to verify finding and build the confidence, make the confidence in AI assisted diagnosis, and also boost the trust in care only, because we have made the AI insight transparent. So explainable AI will foster the trust among the healthcare professional using of these tools only. So personalized treatment and care justification, it will provide the tailored plan, because explainable AI will explain how AI suggests a specific individual treatment plan based on the patient data and justify the risk assessment. So it will also help to clinicians about the patient's contributing factors, which is required for personalized risk professionals or particularly decision professional predictions. And empowering the shared decision making, because transparency is very important. That will be rationals allow the patients and providers to collaboratively understand and agree on the personalized healthcare stages. So disease detections, we are using a tumor was found in the frontal lobe and it is the benign brain tumor because the boundaries are very clear. So that has all clearly explained by the AI clinical decision system or bedside decision support system. So external AI clinical support system will explain that to correct the hyperkalemia, inject the insulin. So insulin is required. Now treatment and prescription, that with depression, high blood pressures or other techniques like this XAI CDSS system will provide the personalized treatment. Clinical practice, so we can get the blood test, MRI images, metric test, which will be getting from the users or to the users through the external AI. Yes, we have the stroke patient, so go to the emergency room and right away take the actions only. So actually AI related to drug discovery because target identification is very important. Actually AI clarify why specific molecular targets are personalized by AI. And also it reveals that biological pathway interactions among the promising for drug development, compound efficacy and safety because it provides the insight into why certain drug conditions are there, the candidates are predicted to be effective or it's toxic or normal, highlighting the key chemical structures or property influencing these predictions and optimizing development. So once we'll make a AI drug discovery rational, transparent, and help the researcher make more informed about the decisions, potentially reducing the cost failures, and also speeding up the drug development pipeline. So you can visualize here that external AI integration and impact across the entire drug discovery plan. So nature drug discovery with external artificial intelligence. So positive contribution, negative, then finally the different will come. So likewise we have to improve. Now we'll see the external AI part towards the medical imaging point of view. So where we are going to contribute in terms of improve the accuracy diagnostic point of view because external AI provide a transparent insight into medical image anomalies or explaining the why specific finding are required and why it is very crucial and why it is going to calculate early and accurate diagnostics and precise localization. So when we'll see that through the visual explanation technique, explain AI as a pinpoint extract the region of interest in terms of lessons in fundus images or facilitating the accurate segmentations and supporting surgical plan. And also inform the prognosis by revealing or getting the feature driven AI predictions. So explain AI contribute the better decision as compared to decision progress and personalized assessment of treatment effectiveness. So these are the techniques which are using readily, silency maps and heat maps, feature attributions and counterfactual explanation. These are the popular techniques we are using like that. So silency map and heat map is very crucial because visual overlay would be provided. So heat map generated by various technique like CAM or some other technique directly on the medical images which highlight the specific reason, specific pixel which will influence the AI predictions and diagnosis. And also we can highlight the critical area like visually we can answer where the AI is looking, showing the clinicians that exact anatomical areas, anomalies which will lead to the model's conclusion and enhancing the particular trust. So by providing the clear visual explanation, so silency maps and heat maps help to radiologists or clinician people to understand and trust the AI, provide the particular reasoning or aiding the interpretation properly about the complex medical images. So we can get it here. These are the X-ray images are there. These are the heat maps are there. These are the silency maps are there. So we can identify the COVID-19 pneumonia normal X-ray images first, second, and third column, which is the figure illustrated the original X-ray images of each class, and there is a heat maps are there, silency maps are there that was generated by the RISE approach respectively. So source from the particular research work that is gamma based example of deep learning, which we have seen that Under that we can use it. So feature attribution, which will be very important because we want to quantify the critical feature. So we must compute the precise features, assign the scores for a specific visual characteristic like texture, shapes within the image that can directly influence the AI prediction. And also we can enhance the model interpretation because we are going to reveal what way AI focus and help to clinicians and researchers to understand the model decision making process or ensure that logical reasoning. So when we want to counter factual explanations because we want to identify the decision boundary, we want to access the model robustness. So the technique is very important because technique must identify the smallest alteration of medical images which will cause the AI to change diagnostic or predictions. And also we need to show how sensitive the AI is to be the minor changes. If it helps to clinicians and developers to understand the reliability and confidence of the model's output. So for that, various radiologist modalities are available. They are using the Explainable AI like MRI or CT scan or X-ray imaging or ultrasound imaging. So Explainable AI in MRI scan which will be required for interpretation of complex deep learning outcome, which will be clarify the deep learning model decision are integrate with MRI data or not, improve the transparency across the tumor segmentation, classification, and radiomics, and precision in brain tumor analysis. Because when we are talking about brain tumor diagnostic, Explainable AI will provide the silencing map or feature attribution, which will completely highlight and quantify the influence of MRI regions, MRI features, which will guide the precise relation, localization, and characterization. And also we can build the clinician trust also. So when we'll explain the AI reasoning, Explain AI overcome the black box challenges, which was the major challenge for the clinician point of view, because we can boost the clinician confidence, accuracy, and about the accountability of MRI based brain tumor prognosis. This is the visualization of MRI input alongside grade cam heat maps. So we have received that the data from Frontier AI MRI visible approach for 3D brain tumor detection. Okay. So Explainable AI will apply in CT scan because we are going to enhance the diagnostic transparency. It clarify AI reasoning for diagnostic in CT scan, particularly for condition like pneumonia and COVID-19, or particularly providing the visual explanation. So we will get the visualize AI because the technique grade cam and lime, it will generate the heat map about the CT scan images only. And we can show that precisely which area for AI consider most relevant for its predictions only. So when we'll apply the Explainable AI in X-ray imaging, we can accelerate the common diagnostic because Explainable AI will improve and enhance the speed, accuracy in the common X-ray diagnostic, especially for the pneumonia classification, lung abnormality, nerve segmentation, fractures identification by providing clear explanation. And also we can highlight the clear reason only. So technique like red cam and lime will generate the visual heat map. By that way, we can precisely indicate the area. Sometimes lesions, bone breaks, or inflators are there that will be influenced by the AI diagnostic. So this is the first result, line-based explanation of disease classifications, explain AI visualization using red cam and line. So we have seen that explain AI technique will be helpful for chest radio imaging through human-centered lens. Now we'll see the Explainable AI in ultrasound imaging. So tumor region can be highlighted easily. The area of the suspicious or malignant area in the ultrasound will be identified very easily by using Explainable AI. And we must be able to align them with clinical annotations to support the accurate diagnosis. And also key sonographic features. So Explainable AI will provide the key sonographic patterns like echogenicity or texture irregularities, shadowing that influence of the AI classification, helping the radiologist for interpret the subtle indicator in soft tissue imaging. So here for the input point of view, this will be input image, radiologist image B, and by that way we are going to identify malignant annotations. Third, simulated region. Fourth, region of interest that has identified by Explainable AI.
So explainable AI used for the oncological ultrasound image analysis. Here final generated image by line explanation why the case was classified as a malignant. Now we'll see the explainable AI the application in terms of computer vision. So we can see the explainable AI why matters in computer vision, because in computer vision we have the complex visual model. So it will provide the transparency while using of such complex model. A system will interpret the images by that way, and also we can enable the human users to verify the particular decisions for task classification, detections, segmentation, and anomaly. And also we can expose the model reasoning, because explainable AI build the trust, detect the bias, and improve the reliability in real world computer application. So that is the important part here, because we can visually highlight the image area where the feature of AI model focus on classification or revealing the particularly why model consider the most relevant only. So for image classification point of view, explainable AI will provide the step by step or summarize the internal reasoning, and also will provide the neural network layer contribution. So where image has misclassified, it will provide that exact visual clues are there or anomalies are there that will mislead by the AI. So we can enable the debugging and model improvement. This is the training data which we have trained and which we have implemented 2D CNN. By that way, we are able to predict the car with respect to mean average pressure only. So why this car? How did you predict it? That means we'll give the explainable model, which will create. It is the because it has two wheels, it has lights, and it's a visual feature obtained from model, and height are different feature which will clearly given that this is car. Just answer will be explained, so that's the reason we can understand why this is explained in the car. So object detection and localization, this is very commonly area which can be utilized, which is clearly why bounding box is drawn, where the bounding box need to be drawn. What is the reason bounding box has correctly not identified the complete object? All these visual feature within the region will be highlighted, and also uncover the contextual influences like neighboring object or occlusion objects, or contribute the detection is distant or not. So in case of when we sometime will miss the some object or false detection also will be there. It will help to diagnostic the root caused by the revealing inaccurately influence the is ignored feature, which feature was not considered or identified model refinement. We can see this is the segmentation by which we can identify the particular object, and we have segmented them. With respect to segmentation, we are going to identify the mean average precision only. Transparent semantic segmentation. So explainable AI, as we have seen that we broke down how model will assign the each pixel to the class. That means pixel belongs to that class or not. So spatial prediction is very important here. So this model, which will be visualize the transition at class boundaries, revealing what we define the reasons from each other reasons are there. Then clear segmentation will explain the high stacks applications like tumor boundary has been identified or urban map has been generated only. So explainable AI has been used for the instance segmentation also, because the model will differentiate between individual object or same different class only, and it will highlight the unique pixel features for each case only. And also we can say that clarify the rationale behind precise each and mass generations, reveal that visual cue that define the exact boundary of detected object. So we can understand that explanation is very crucial for application, which is required for object specific manipulations, analysis, robotic grasping of individual items, or detailed medical analysis, which will be obtained. So we can say here semantic segmentations. By that way, we are going to identify objects and just pixel. No object, just pixels only here is. By that way, single object we are able to classify and localize. By object detections, we can see that we can draw the multiple bounding boxes. By that way, we are able to detect. Or insert segmentation, three different label would be provided for segmentation of this object only. So interpretable anomaly detections, which we can be used by explainable AI, which will provide the visual pattern or reason which will be deviate from learn parameter only. So it's also allow the operator to trace the source of anomalies where the structural behavior or contextual behavior will be identified. And interpretability is very crucial for reducing the false positive in a particular domain like defect detection, security monitoring, or medical anomalies scanning are there. You can see here, this is the explainable AI detections using vision transfer. So data collection and reprocessing, then binary classification, resizing, then vision transfer is developed for the model linear projections of flattened patches, normalized, then head will be connected, then we'll send to the result with respect to convolution map. We identify the anomaly, then we have created the feature map, then flattened feature will give to the fully connected layer, and that heat map are able to provide. Then explainable AI will be detected this portion. So explainable AI is the answer, because as we have seen that previous cases in black box AI problem, we will offer the explainable AI to solve the problem of transparency, understanding, explanations of the decision, and build the trust, especially in the critical field like healthcare or finance. And healthcare will improve the patient safety, enable the professional to validate AI reasoning, and also it accelerate the AI integration and continuous improvement in clinical set. And beyond the healthcare, external AI having the vital role in computer vision tasks like image classification, object detection, segmentation, or image interpretation will help to verify decision, detect the biases, and improve the decision reliability. So broadly, it has the application in healthcare like transparent clinical decision support system. So Explainable AI has provided the solution in drug discovery, in medical imaging like Silency Map, visually highlight the critical reasons of diagnostic across various scanning. We'll see one or two
Sir,
cases. Yes,
sir,
madam.
certain questions are posted in YouTube, which has been put up in chats of MS Teams.
Yeah, let me know the questions.
It's in chat, sir.
Chat. Okay. Just 2 minutes. I'll just conclude it here. Chat. I did not get any message, ma'am.
Sir, in Teams it is there, no, sir. I'm able to see that.
But here for me, I am not able to see anyone. You and sir is there only. No message I am not able to see. Now it is coming.
Yeah, yeah.
Yes, you can use explainable AI in skin cancer classification. Some important point means general flow. That means what is the normal model you are using. That means you are how to integrate AI and DL for disease predictions. So you want to integrate for the what is the purpose, because deep learning what you are implementing, that means you have suppose you have received the output or you receive the correct accuracy in diagnostic accuracy, but you don't know what is the reason or whether you can believe on that result or not. So what Explain AI will tell, if you are replacing deep learning to Explain AI, you may get it that what is the reason in the different applications which we have seen here. So you can see this case study here. So in this case study, it will provide the clear reason. You have the output like a visual explanation. You have the output of case-based explanation. You have the output of textual explanation. So you have the output of auxiliary explanation. So all these approaches, we are getting the result. So that explanation, if you give clearly to the model, which will provide. So in that paper, they focus non-visual methods, which will categorize in auxiliary explanations, which we have given case-based explanation, which will give a textual explanation. So same way in the object detection, we have seen that the car has classified. But why car has classified? So that means clear feature attribution will be given to the model. First thing, when we implemented deep learning model,
we were just only implemented a model which with respect to particularly number of layer has been added, and by that layer we are able to extract the feature. Then we fit the feature to the classifier. Finally, we classify cat as a cat or dog as a dog, like that. But now we will go back to the task. We will clearly will give the which feature are very important and crucial. But why? Because of that feature only. So that may be textual features, that may be visual features, that may be different features. Explanation would be given during the model implementation. That is the major part here, which can be added in this case. So we can see here, like this is the deep learning model which we have implemented. So normally you are applying the model implementations, like these images are there, top activated images. This is interpretation, and this is the top activity. That is the interpretation of chest, and this is model you are implementing. So you ask the question of skin cancer detection. So what you are doing, you are taking skin cancer images, you are applying, these are the layers are there. This is the feature extraction. So feature extraction, what exactly will give the idea? That means that images interpretation would be added. So that skin area separated from that. So interpretation would be given, score would be given. Same way after that, this all feature will be concurrent to fully connected layer and will fit the output. So here the interpretation would be identified just only. So that is the duplication of top activated images for two exemplary units of CNN base made is dataset. Now input image captioning with visual explanations, that will provide the visualizations where we are getting the, that means AI system performing the image captioning with visual explanation, and this is the report how the impression would be there. So these two tasks will be taken from input image. So auxiliary measures will provide the quantitative informations on model predictions like uncertainty or importance scores or prediction interval, and these measures are presented in tabular form or graphical form. So this is the popular technique to visualize the data in 2D or 3D based on the neural activation, and visualize data will provide the interpretation with data, validate known pattern and identify the area of model improvement on. So this is the interplay between the whatever the epistemic and aleatoric uncertainty will be there. So dashed line represent the approximation function, where the blue dots represent the samples from the training data. So it's a high uncertainty here. This is the two different uncertainty would be there. So when we'll talk about explainable AI in healthcare, that means the integration with smart wearable devices will greatly improve the health condition, but black box nature of AI model. That means if you are using normal AI model, cause the lack of trust, lack of accountability, and we cannot believe on the decision. So this limit effective use in healthcare. Explainable AI needed to provide transparency, result tracing, improve the trust in that. So several techniques which are using in healthcare, leveraging AI, IoT, cloud computing for real-time monitoring. So AI will just provide the black box concern, but explainable AI provide the transparency, enable the result tracing and model improvement. So related to that, this generating insight using AI and clinical expertise, health data, AI model predictions. Now explainable AI will explain whatever the clinician knowledge has gained, predictions is correct or incorrect. If it is correct, insight or recommendation. Incorrect, then go back to create the improve the model. That is the procedure we are doing. So explainable AI for deep learning based medical imaging classification. So we want to improve the higher accuracy in medical images classification, but we are suffering from poor interpretability, that is known as black box problem. So these are all applications. We can just see that explain of X-ray images in that data sets. The architecture of V16 of X-ray images. This is the line explanation. That means the architecture which is used for three different classes, why the predictions are improving.
So now I'll conclude that. So explainable AI enhances the transparency, trust in AI-based medical imaging in healthcare decision. It helps to clinicians understanding, validate the AI predictions, improving the collaborations and accountability. And also, explainable AI contribute for safer and more ethical deployment in AI healthcare. And when we are going to see the ongoing development of explainable AI is very vital for advancing reliable and effective AI-driven medical solutions. So in the future directions, interpretability of the model can improve. Clearly, we can provide the details. Human understandable explanation also for AI decision, medical diagnosis can improve. Visualization method also, which can be given by using of heat map or silencing map that highlight the specific reason in medical imaging that influence the AI prediction. And also it integrate the clinician workflow because this system will seamlessly support the clinicians by offering explainable insights and fostering trust. And validation and reliability also will improve because explainable AI will ensure that explanations are accurate, consistent, and clinically relevant to improve the decision making model. So that's all from my side.
Thank you, sir.
Yeah.
So, since we are running a shortage of time,
Yes, ma'am.
it was based on the feedback of the participants. We have come to know that it was a very informative session, sir, but telling about where explainable AI can be used in different applications.
Yeah.
It was a very informative session and it was so useful for the person who are doing research. I think that it would have been a very good information for them and they would have extracted lots of data based on the content which you have delivered today. Thank you, sir. Thank you a lot, sir.
Thank you.
Thank you for sparing your time, sir, and accepting our invitation and engage us for last 1.5 hours.
Thank you. Thank you.
Thank you.
Thank you
Thanks
for
a lot,
inviting.
sir.
Yes.
Thank you, sir. Now we are moving on for day 5, session 10. And the guest of the day for session 10 is Dr. Mirza Khalid, who is from NIT Rourkela, who is working as assistant professor at Department of Biotechnology and Medical Engineering. His specialization is in medical electronics and instrumentation and applied microbiology. He leads research in AI-driven models for healthcare applications, particularly in improving blood sugar prediction for diabetics management. He has developed an innovative machine learning model using multi-head attention layers for accurate glucose forecasting, which is published in IEEE Journal of Biomedical and Health Informatics. His research aims to make digital health solutions for diabetics management more accessible and efficient, including integration with mobile apps and smart insulin pumps. He serves as a faculty advisor contributing to student activities and innovations at NIT Rourkela. He is recognized for interdisciplinary work, bridging biotechnology, medical engineering, and artificial intelligence in healthcare. We welcome you, sir.
Thank you very much, madam. Am I audible?
Thank you, sir. Yes, sir, you're audible, sir.
Okay.
So can you please share your screen so that we can check?
Yes. Yeah. Just give me 1 minute. Is it visible? Screen?
As of now, yes, sir, it is visible now.
Okay. Thank you very much for the nice introduction, ma'am. And thank you very much for inviting me to your. Thank you.
Welcome.
So thank you very much. Okay. Yes. So thanks a lot also to Dr. Praveen and you for inviting me to the workshop, the FDP, Faculty Development Program. So in today's talk, it's I understand it's late evening and it's difficult for participants sometimes to focus. I will try to finish it on time. Basically, my topic today is to look into explainable and generative AI for medical data analytics. So in today's session, we will look at various aspects of, first of all, this talk is actually divided into 3 different parts. In the first part, as many of your participants are from diverse backgrounds, so we will focus on a specific medical need. As you said, I work in diabetes related applications. So I will introduce a new concept. It's called as closed loop medical devices. And we'll see how in closed loop medical devices we can use time series data analytics to enhance their performance. So I just noticed that the previous speaker also was working on medical imaging data. So my focus will be mostly on time series data, and I hope it will be an informative session for your participants. And I wish them all the best. And please let me know if there are any questions. So what? So in pharma, actually, they have a different terminology for Moore's law. They also observe. So Moore's law is an empirical law. It's not a physical law or anything which is there in nature. So it's more of an observation. It's more of an empirical kind of thing that has been observed. So compared to that, in pharma, they have something called as Eroom's law. So pharma actually, they have seen that if you look at this plot here, as the number of years are increasing, as we are moving into the 2020s decade, so this data is until 2010. So you see that the cost for developing a medicine is actually increasing. So the productivity is actually decreasing, meaning you need more money to develop a certain molecule for a specific application. So this actually got some pharma companies to think about how to where the next innovation is going to come in the domain of treatment and pharmaceuticals. So there were some people in GSK, GlaxoSmithKline, who thought that we can actually start something called as electroceuticals. So this is the starting point of electroceuticals, the justification of why we look at electroceuticals. So electroceuticals essentially is a way of treating diseases by through electrolysis, you can say. So as you can see here, it was actually a person called Chris Pham who first coined this term called electroceuticals, and then the whole kind of process started. So his idea was more focused on treating diseases using electronic systems by intervening with the nervous system. But the same concept, the concept that is there in electroceuticals, can be further expanded in addition to the disease burden. So closed loop medical devices actually try to shift that burden from patients to machines. So that is the medical devices. It's mainly to shift the burden from the patients, from the caregivers to the device. So meaning the if somebody is undergoing certain therapy, then that therapy should lead to better clinical results. So closed loop medical devices and autonomous medical devices, they have been shown to actually improve your therapeutic efficacy also. There are many papers, there are many this if closed loop medical device, that is the topic in today's talk. And also when we are actually using that AI, we will see that how we incorporate interpretability or explainability to this topic, to the AI, so that we have more confidence on the decisions taken by the AI. Okay, so with this we move on. So yeah, so like I mentioned, the vision is to shift the burden of disease management from patients to machine. That is the philosophy of having closed loop medical devices. So there was actually, just to give you an idea, so here you can see the EVP or the Vice President of Medtronic Diabetes actually, she actually said in one of her talks that for a diabetic patient, around 180 decisions they have to take in a day. So which is a massive amount of decisions that they need to take in addition to the day-to-day life, career and everything. So if ideally, if this number of decisions is shifted to some other decision maker, let's say AI, then it will be easy for them to lead their life. It will be less stressful for them to lead their life. So that is the vision behind closed loop medical devices. And today we'll see how AI can enable closed loop medical devices. Now coming back to our regional scenario, this figure is from a study done by ICMR very recently. It's called as the India B study, ICMR India B study. It's essentially a prevalence study. You see that the prevalence of diabetes, and then we have the prevalence of pre-diabetes. So essentially, if you combine all of these, you see that the prevalence of diabetes is around 11.4% according to this study, and pre-diabetes is around 15.3% according to this study. So prevalence levels are quite high in India. So imagine a scenario, the worst case scenario. So generally as engineers, we look at the best case scenario, the worst case scenario. Some of you who might be doing software testing, they might know about these different scenarios that you have to test your software. Similarly, from a medical perspective, the worst case scenario is if all the patients who are in pre-diabetes, they convert into diabetes or they move into diabetes, that is the worst case scenario, then the prevalence level of diabetes will jump to around 27%. So almost 1/3. So that is a very difficult scenario. And we should be prepared for the best case scenario as well as the worst case scenario. And we should try to treat the pre-diabetes and prevent pre-diabetes from converting into diabetes. So anyway, this is just to give you an idea of the amount of the volume of problem that needs to be solved. So in order to solve this problem, there are many ways actually. So this artificial pancreas is mainly directed towards type 1 diabetes, but recently doctors are also trying to adopt this technology for type 2 diabetes as well. Those of the type 2 diabetes who are on insulin support, who are taking insulin. And also sometimes doctors use only sensors to improve decision making in patients who are not taking insulin as well. So the applications of this software of the closed loop therapeutics is quite large, and it is increasing day by day. So this is to give you an idea of the closed loop. What do we mean by closed loop? Let's say we have a sensor that is monitoring the glucose level, and then the algorithm actually decides two factors. There are two things that it decides: when and how much. Okay, when to inject insulin and how much insulin it needs to inject. So these two decisions are fed to the pump. Then once the insulin is injected into the body, naturally glucose level is affected, and accordingly this loop goes on. So that is why we call it as a closed loop medical device. Okay, this is a picture of the device. So you have an insulin pump and the sensor. Nowadays, previously sensor used to be around the waist, but nowadays the sensor used to they implant it here on the triceps area over here on the back side of the arm. And then you can use it to actually do it. So this is how the sensor looks like. And interestingly, this sensor is not invasive as in that it goes into the vein or it goes into some blood vessel. It's actually monitoring the glucose from the interstitial fluid. So it is actually subcutaneous, and it is actually monitoring the glucose level from the interstitial fluid. Now, when we monitor glucose level from interstitial fluid, it is good from a sensing perspective because the sensor lifetime will be longer. There will be less reaction from the body on the sensor. So biofouling, coating of the sensor will be less. But there are some challenges from the engineering perspective. So those challenges we will see, and we'll see what are the challenges, how AI is able to handle those challenges in the subsequent slides. So again, to give you an idea of how it happens. So here we have the blood vessel. I know this is a bit of a biology, but I believe in today's world, we need to have some idea of the biology so that we can develop solutions for the target applications. So here we have the blood vessel. From the blood vessel, there are some plasma which leaks out. So in the blood vessel, we have the plasma, and it has many chemicals, and these chemicals actually leak out of the blood vessels. Depending upon the size of the molecule. So smaller the molecule, easier to leak out. So glucose is a small molecule. It has size less than 3 kilodaltons. So it leaks out and it goes into the interstitial fluid. Interstitial fluid is the fluid which is present between cells outside the blood vessels. And then we are sensing from the interstitial fluid. So generally we sense from the dermis, which is around from the skin. If you go to the depth of 1 to 3 millimeters, then you are actually accessing the dermis. So if you go deeper, then you will access the hypodermis and you will puncture some of these capillaries and you might draw some blood. Anyway, so generally these CGM sensors, continuous glucose monitoring sensors, they actually mostly monitor from the dermis. They are supposed to get from the interstitial fluid. So it all sounds nice and good from a sensing perspective. We are not drawing any blood, easy to implant. You can monitor glucose continuously. But and this is how it looks like, the sensor. There are three main companies. One is the Abbott, and then we have Dexcom, then we have Medtronic. There are new companies also in India. There is also another company, Sinocare, which is in India. Actually, we generally get Medtronic. We can buy Medtronic sensors. We can buy Abbott sensors. Dexcom, I believe, is not probably not available in India. There's also another company called Sinocare that also has launched last year. You can buy it off Amazon probably. But Abbott, Abbott Freestyle Libre, you can definitely buy from Amazon. To buy Medtronic, I think they have their own sales representative. You have to contact them and buy them. And they only sell mostly to patients or doctors. But this is how the sensor is. Mostly it is implanted on the hand, the arm, the tricep area mostly. And then you can actually sense the glucose. And all these sensors are enzymatic sensors. They use an enzyme called as glucose oxidase. Anyway, so without going much into the biology or the sensing, let's come back to the engineering, the interesting part in which you and I are both interested. So as I told you, we are monitoring the glucose levels, or the sensor is actually monitoring the glucose levels from the interstitial fluid. Now, from a modeling perspective, biophysical modeling perspective, if you are actually monitoring the glucose from interstitial fluid, it is actually acting like two different compartments. One compartment is your blood vessel and the other compartment is your interstitial fluid. Okay, so with this you can actually make a two compartment model. And when you have a two compartment model, when you have two compartments separated by a membrane, let's say this is the membrane. So if there are two compartments separated by the membrane, then actually you have something called as diffusion, which is happening here. Okay, and because of this diffusion, there is a delay. There is a delay between the time when glucose changes in the blood vessel compared to the time when actually that change is reflected in the interstitial fluid. So remember, the origin is actually the blood vessel. That is where the glucose is changing, and that change diffuses out into the interstitial space. And this, because of this diffusion process, there is a small delay, and that delay is close to 10 to 12 minutes in depending upon different individuals, 10 to 12 minutes according to this paper recently. On an average, you see around 10 to 12 minutes of delay between the blood glucose level and the interstitial glucose level. Imagine the glucose level is changing at time t equals to 0. The same change is being reflected in interstitial fluid at time t equals to 12 minutes. Okay, 10 to 12 minutes. This delay actually creates a new set of problems. So this is how actually the closed loop medical device looks like. So you have an objective, control objective. Control objective is to maintain the glucose level within a certain range, let's say 70 to 120 milligrams per deciliter. That is the objective. We have the controller. The insulin pump is like the controller, or the algorithm is the algorithm is the controller. The model which decides how much insulin to pump, when to pump, and insulin pump is the actuator. So this is the actuator and this is the controller. So if there is a delay from the sensor level, if there is a delay from here, then the entire loop is actually affected. Okay, so previously people have tried using PID control, the standard, the best, the bare minimum control system that is available. People have tried to model the behavior of beta cells, the cells which are secreting insulin. Recently, people have started using these deep learning based approaches to actually account for the delay. 10 to 12 minutes delay is there. In order to account for this delay, in order to prevent this delay from affecting the decisions, people try to forecast glucose levels in advance. Okay, so they need to forecast this glucose level in advance so that they can actually the effect of delay is not there on the pump, the entire operation of the pump. And this time series, this actually forecasting, if you look If you break it down, it's actually time series forecasting. You are essentially forecasting what will be the glucose level at time t equals to 15 minutes, what will be the glucose level at time t equals to 30 minutes in advance, half an hour in advance, or 1 hour in advance, or 15 minutes in advance. So generally in this field, we have three different prediction horizons: 15 minutes, 30 minutes, and 60 minutes. This, although we are discussing from a biological perspective, a medical application, a healthcare application, but the same model can be adapted to other applications as well, depending upon, let's say you are working in stock forecasting. You can use the same model or adapt the model to your application, but essentially it is same time series forecasting. So you will see how we are actually applying different AI models to this, where interpretability is used, and how to deal with these different problems. And you will see that somewhere generative AI is also needed, and we'll have a look at it later on in this talk. So how do we do time series forecasting for medical data? What is needed? So when we talk about time series forecasting, the first thing that comes into our mind is RNN, recurrent neural networks. Improvement of recurrent neural networks is actually LSTM. Compared to LSTM, there are some improvements in GRU. And this is a relatively new network, which actually was introduced in, I think, 23, around 23 or 22 maybe, in a paper where the senior author was Yoshia Bengio, who is one of the pioneers of AI. The paper is available in reference. I'll share with Dr. Praveen and Madam, and you can access from there. So neural basis expansion networks. So we'll look at all the three models. We'll start from the base model, and then we'll go up and up and up and see how this model is better than all of this combined. Okay, so recurrent neural network, as you might all know, just to go through some basics, I'm not sure whether you require anything like this or not, but still let's go through this. It's a set of models where there is a feedback, where the past output is fed back as an input when we are actually forecasting for the present, for the present input. When we are calculating what will be the present input, we are actually taking the past output. When we are calculating what is the present output, we are taking the past output into account. So essentially, this is something called as unrolling through time. So when you are training the model, you are unrolling the network through time, equals to -1, -2, -3, and you are training it individually. So in that way, it's called as unrolling through time and training a recurrent neural network. Now, this is the activation function for a recurrent neural network. As you can see here, we are using the current input, past output, and then this is these two are actually needed. So you need to focus on the present input, and we are using a past output. And when we are training the model, we are unrolling the network through time. Moving on, there were some problems with RNN. The main problem was that RNN was not able to deal with very long sequences. In order to deal with that, we came up with LSTM. People came up with LSTM, okay, long short-term memory. So here you have a long-term memory and a short-term memory, and both of this is captured using different gates in an LSTM. So different inputs, so that past output actually is broken down into a long-term and a short-term state, CT-1 and HT-1. And depending upon whether you need both or whether you need only one of these, you can control whether you make the output dependent on only one or both of them. So that flexibility is there in LSTM. The downside is you increase the number of model parameters that you need to train. Okay, so if let's say we need to actually forget certain past state, then we use the forget gate. We have the input and the output gates. So different architectures are there to control which input. So whether do we need CT-1 or do we need HT-1? So to have some control over the contribution of the different states on the output, we have these different gates are there. All these gates are actually activation function is actually sigmoid. So it can be either 0 or it can be either 1. So in that way, you can actually control the gate. So these are the different functions. That is for a single unit of LSTM, you need 6 different activation functions that are used to train. And there is a nice animation which I found online, as you can see. So these sigmoid figures, these are actually gates. So you can control the operation or usage of these. So this is one gate. So you can control the operation of this particular activation function using this gate. If this gate is off, then accordingly the input is eliminated or used in that way. So these are these presentation, of course I'll share with the organizers, and they can actually share with you, and you can have a look. This actually I found a nice animation online, and it gives the idea very clearly how LSTM is working. Moving on, again in LSTM, due to increase of parameters, there was a slight increase in the training time. So compared to the RNN, so you can actually use an improved version is actually GRU, where we are back to the single passed output, but there are some combinations of this single passed output. Okay, so GRU has certain advantages. So compared to LSTM, so here we have separate, in LSTM we have separate hidden and cell state, or long term and short term state. So here it has been combined. Okay, and as you can see here, the main advantage comes here. So if you look at the GRU versus LSTM comparison, so if you train a model where there are 16 GRU cells and 16 LSTM cells, then what you will notice here is the number of parameters actually. So here GRU has less number of parameters compared to the LSTM, even though the number of cells are same. Training time accordingly is slightly higher for LSTM, which is 2 hours 30 minutes. Compared to that, it's 2 hours 15 minutes. So there is some savings in terms of training time. Accuracy more or less is similar, but so you can get the same accuracy as an LSTM with less amount of training time, with less number of parameters. So definitely it is a win-win for us, especially if you think of, let's say, deploying this model in a resource constrained environment, then GRU is the preferred option compared to LSTM. So these are some advantages in comparison between LSTM and GRU. So with less number of parameters, it can achieve similar accuracy or performance compared to an LSTM. Anyway, so that's all about GRU LSTM. And now coming to, so you remember in GRU or LSTM or RNN, the fact is you are actually using a past value of the output. Okay, so what people thought that, okay, can we use a fully connected layer? Can we use it to actually do forecasting? So that thought actually is captured here in neural basis expansion networks. So here the structure is like this, where you have a fully connected layer. So first of all, you have multiple stacks, and within each stack there is some block, and within each block there is a fully connected layer. And this fully connected layer actually is divided into two parts. One is called as the backcast, and the other one is known as the forecast. So backcast is actually this backcast is actually replacing your past output. So previously we used to take past output, so that past output is actually replacing the backcast. The backcast is actually replacing the past output that we had in GRU, LSTM, or in RNNs. And then you use these different blocks you are stacking together. So as you can see, the forecast of course goes out as the forecast. The future backcast is again used in the subsequent block to create the next forecast. So the idea is here, the backcast essentially is modeling the interrelationships between the different time points. Okay, so this time point, the interrelationship between different time points is actually captured by the backcast. Okay, so this is a new network, neural basis expansion network, and the advantage of this network is interpretable, meaning if you are getting a certain forecast, you can explain why a certain value is being forecasted. So you have some idea of why a certain. So we'll look at the interpretability also. So the way they do interpretability in this n-bits network is they have relied on a very old statistical paper. So if you look at this paper, This paper is from 1990s. Okay, so this paper actually says that you can interpret data by decomposing the data into two components. One is called as the trend and the other one is called as the seasonality. Okay, trend and seasonality. So both this trend and seasonality is you can actually implement it here in this network. You can have trend component and you can also have a seasonality component, and then you can use the trend and seasonality component to explain the occurrence of data. For example, if you look at this data here, it looks periodic, okay, but overall it is actually increasing. So you can explain that at any one point of time, the repetition is due to seasonality, and the increasing nature of the forecast or the graph is due to the trend, because the trend is going up, the data is going up. If there is and the small short term changes in the data, you can explain with the help of seasonality. Okay, so same way, this is the output from the n bits model. So you have a trend component, you also have a seasonality component, and by combining these two components you can explain whatever forecast is happening. That is the approach. That is how we are actually going about the problem. Moving on. Now the first, this is one of the models which we recently developed. So initially, before the n-bits approach, we thought, okay, can we use something called as what happens? Okay, GRU you can use, LSTM you can use separately, but what happens if we combine both of these GRU and LSTM like a hybrid network, and we have a wide deep network, meaning let's say these are the different inputs that are affecting your glucose level, the past CGM values, past glucose values, past insulin dosage. If you are doing any physical activity, that also affects your glucose. And then what is the meal that you have taken in the past. So what and we have validated it actually in a clinical data set. So here looking at these four inputs, we thought of using a wide deep network with a hybrid combination of GRU and LSTM. So let's say wide deep means you look at this input here, this pass CGM, it goes through multiple layers. It goes through a GRU layer, it goes to a LSTM layer, and then again it goes through GRU. Whereas this input, which is the less significant or less frequently occurring input, is going only through one layer, the GRU layer. Similarly, physical activity also is going through one layer. This one is going only through the GRU layer. So different inputs are going through different set of layers. So that is called as wide deep network. And we also wanted to see what happens if you combine GRU and LSTM together in a hybrid network. What is the whether there is any advantage in doing this or not. So I will show you what is the advantage and disadvantage. Anyway, so these are the forecasting results. As you can see, they are overlapping nicely. The only problem is this network is having problem in forecasting the points where some points it is whenever it is there is a dip and the forecasting accuracy is not that good in those places. So now let's have a look at the advantage. So if you train only a GRU network using this data, using the same set of inputs, then we observe that the training completes at around epoch 25. So one epoch is taking around 4 seconds. LSTM, it is finishing at epoch 22, and one epoch takes around 5 seconds, slightly more than the GRU naturally because it has more number of parameters. So just remember this 25, 22. Now if you go with a wide deep approach, wide deep network with GRU LSTM combined, you look at the stabilization, it actually gets trained much faster. Okay, so that is the advantage. If you go for a wide deep network, it actually trains faster, and the epoch also takes less time to train. It's only 1 second. Previously it was 4 seconds. So that is the advantage of using a hybrid network, and also you are actually training faster. And performance wise also you have seen this, it is good, but the only problem is there is a delay between the input. So if I remember, we'll see how much the time delay is. We'll look at the time delay. So there is the time delay approximately is, so these are different parameters, these are different, so these are actually tested on clinical data, and these are the different ways to assess the goodness of the forecast So you have root mean squared error, you have mean squared error. Then we have MARD, mean absolute relative difference. This particular parameter is very specific to glucose forecasting applications. So you see, we get a good result here in terms of the MARD. So typically for sensors, we say that the MARD should be less than 10%. So it is way less than 10%, which is very good for us, which indicates that the network is working quite well. And then we can look at even patient-wise data. You can have where you have physical activity and no physical activity. So you have a data set where there is physical activity present. You have a data set where no physical activity is present. So in these way, different combinations you can try and test for. I think the main problem that we encountered here is the delay between the forecasting delay. So it was coming out to be approximately 15 minutes for a forecasting horizon of when you want to forecast for a prediction horizon of 15 minutes. The delay itself was around 5 minutes, if I'm not wrong. So for 5 minutes, it is for 15-minute forecasting horizon, it was 5 minutes. For 30 minutes, it keeps on increasing by 10 minutes and then 15 minutes. For 16 minutes, it would be 15 minutes. So in this way, the problem was so there were two problems. One is the time delay, which is which we call as time lag. And the other one is the another problem was we wanted to see if we are able to improve the forecasting accuracy also. Now this is another legacy, you can say, from the glucose forecasting domain, which we call it as the Clark grid error. So this is also used in some engineering applications. So here you can see that we have the reference concentration and the predicted concentration. So ideally this should be a straight line. Okay. But things are not ideal, of course. There are some minor differences. So if all your predictions, they mostly lie in the region A, then it is very good. Region B is also considered acceptable. Region C has some risk, and D and E are high risk. So you don't want to have any points or very, very less number of points in D and E. Okay. So this is another clinical application related plot that is called as the Clark error grid. Now, all of this is fine. Yeah. So now we can see the time delay. So if you look at different previous works, so our time delay is slightly higher. So it's around 5, but accuracy is better. So compared to other works, the accuracy, the performance metrics are better. Mean absolute error and root mean squared error and MARD, they are better compared to the previous works. But yeah, of course, the problem is delay. And so this delay somehow we need to solve. So what is the solution for this? That we will see. So if you look into the previous work, you see that there is a problem of delay and there is a problem of lack of interpretability. So these models are not interpretable. We don't have the trend and seasonality components. So in order to solve this problem of delay and maintain the accuracy, the performance, and or improve the performance, as well as you have interpretability, we use something called as neural basis expansion network. So this network we have used from the previous network, which I had shown you. There are multiple stacks. Within each stack there is a block, and within each block there is a fully connected layer. So that network originally was meant for fully connected layer with only one output. So this you can actually adapt for multivariate. So we can actually adapt it for multivariate forecasting, and within that you can add something called as the multi-head attention layer. So this attention layer improves your accuracy, the performance metrics quite significantly. So we'll see. So essentially what we have done is we have looked at different networks. So we have converted the univariate neural basis expansion network into a multivariate multi-head attention layer driven network to solve the problem of delays and to solve the problem of improving forecasting performance metrics. So all of this, as you can see here, compared to the previous network, you may have noticed or you may remember that the network is not performing well whenever there was a dip. Now you can see they are very nicely, they are matching the predicted value. And here, as I move on, the MARD is also lower compared to the previous network. And this the same data set, it performs well. And the important factor here is we have the trend and seasonality component. So it is partially interpretable. What happens is you lose some interpretability when you add the multi-head attention layer. So that interpretability is actually lost in some places, but you can to some extent extract the trend and seasonality components. So this trend and seasonality. So if you look at this plot here, if you look at the original data, so the original data is the black plot here. Okay, so and the predicted data is the blue plot here, and as you can see, there is a slight delay between the original and the predicted one. Now, if you want to interpret why there was a peak here at this point here, or why the predicted value there is a peak here, you can actually look at the trend and seasonality components, and you can say that okay, the seasonality is dominating at this point, and actually because that is why there is a peak here. So you can interpret in terms of trend and seasonality. So if it is going down or going up, you can to some extent use the trend and seasonality component to explain whether the trend is dominating or the seasonality is dominating. And you can also look at the attention layer actually helps in some way to adding the so it can actually tells us which model parameter is actually more significant or more important in terms of predicting. So that is why we have the attention heat map, which helps us identify which actually which is more important, which is playing a role in the output. So overall performance here, going back, you remember it was around 20 minutes. So here there is for the 5-minute prediction horizon. So we have 3 different prediction horizons: 15 minutes, 30 minutes, and 16 minutes. Now, if you remember, you might ask why it is 15 minutes. Just recall the physiological delay was between 10 to 12 minutes. So we have taken 15 minutes as a bare minimum prediction horizon. So in 15 minutes, there is almost no time lag. Okay. And here the time lag is significantly less compared to previous work. So if you look at this time lag, it is less. So adding this network of using this multi-head attention network and neural basis expansion network, it helps in actually improving the accuracy of performance, forecasting performance. It helps in reducing the time lag. It also helps in adding some level of interpretability to our results. So these are 3. You are getting 3 different advantages combined in one specific network. Now, one of the problems that you might face if you are working with time series medical data, especially in this scenario, in closed loop medical devices, is let's say a person is wearing the sensor and this sensor is connected to Bluetooth. Now, there is a chance that this data is being transmitted via Bluetooth to the mobile. There is a chance that there might be a disconnect between the sensor and the mobile phone. Hence, there will be a loss of data. Now, when there is a loss of data, prediction becomes very difficult. So you have to actually replace the missing data points by using different methods to account for this missing data points and then make the prediction. So actually, what we have done is we can actually use GANs, generative adversarial networks, for imputing the missing data points. So there are many different methods for missing data points to imputing, but GAN actually shows comparatively better performance compared to the other works. So here generally this is the problem that we have. There are some missing data points here in this particular plot. As you can see, there is missing data point here, here, and here. So how do we actually deal with this? So we have to actually replace this data, and when you are replacing, the probability distribution of the generated data should match with the original probability distribution, and GAN is one of the best methods to do that. It's a little bit intensive in terms of training it, but once it is trained, it performs very well. So this is the network that we have used. It's called as the time GAN network. And what we have seen that in the discriminator, so there are many different, so in GANs, as you know, they are actually having a generator and a discriminator. So in the generator and discriminator, if you use for long sequences, if you use LSTM as a generator and discriminator, it performs quite well. And if you use GRE for short sequences, performs very nicely, depending upon the memory capacity of these two networks. So with this, actually, you can start imputing data. So this is the data imputation, where you have The green plot is actually showing the data that is, so this is the missing data point, and that is replaced by the imputed data. Again here, the missing data point is replaced by imputing data. So this is missing data point replaced by imputing data. And the good thing is, if you look at the TSNE plots for these different generated data, it should match the TSNE plots of the synthetic, the real data. Now you have a waveform, you have a time series data which is having generated points or synthetic points combined with real points or real data. Now you can use the entire time series data to do your forecasting. Now you don't have the problem of missing data points that will affect your forecasting performance. Now all the data points are present, and these data points, the synthetic data points, are actually matching the probability distribution of the real data points, and then you can do the prediction. So this is another advantage of using. So you can just see here briefly, this is called as the TSNE plot. So the TSNE plot of original and synthetic data are very similar, which is a good thing, which indicates that the generated data and the real data, they are actually very similar to each other. Much more detailed plot for different, you can see that the spread is more or less matching everywhere, and it indicates that your GAN is generating the expected or the right synthetic data. Anyway, now you can combine the synthetic data, you can use the synthetic data to do your prediction again. So this is just giving us the MARD, RMSA, MARD and all that, using synthetic plus real augmented data set. So this is the MARD with the synthetic, so without and with, and as you can see here, they are actually when you use synthetic data, it is actually improving the forecasting performance. Naturally, it will have better forecasting performance. Anyway, not only time series data of CGM, like continuous glucose monitoring, you can also add, let's say, other types of data, let's say insulin data or meal information. So in this whole application of artificial pancreas, unfortunately, it is not totally automated. Somewhere you have to actually enter the user has to enter the meal amount of meal people he or she has taken, and the insulin data also sometimes need to be entered, so that if somebody forgets or misses due to some reason, that also can be imputed safely, and it is not going to affect your forecasting accuracy in any way. There is also something called as discriminative score, and this discriminative score can be used to assess the performance of your GAN model. And you can see that using using synthetic plus real data, small amount of sequence or synthetic data with real data actually helps in improving the performance of the forecasting performance. Now, I think that actually brings us to the end. So here, what we have here is we have two different performances. So we have actually, what we can see here is we have actually implemented a predictive model and a generative model, and the predictive model is having some interpretability, and generative model is actually relying on the predictions. So generative model is like an assistant for the predictive model. So it is using the generative model is generating the missing data points, and the predictive model is giving your forecasting accuracy, and that actually helps in improving the overall performance of the closed loop device. So I hope, I hope this actually helps you in your applications. So even if, let's say, we move away from the application of closed loop medical devices, let's say in some other applications where you have time series forecasting, you can adopt these models for time series forecasting. You can use combination of GRU, LSTM. The network might be slightly different, inputs might be different, but the concept remains same. So you can also use N-bits. Now there is an advanced version of N-bits called N-hits. So you can either use N-bits, classical N-bits, where you can do univariate forecasting, interpretable univariate forecasting. You can also combine it with your multi-head attention layer if you want to improve your forecasting accuracy. We also noticed that if you are using multi-head attention layer, if you are using multi-head attention layer, it actually improves your accuracy quite a lot. So all of these advantages are there, and we discussed essentially three different networks. The first network is we looked at what is the benefit of combining GRU-LSTM in a wide deep network. That is first network. We saw that the training time was very less. Second, we looked at the problem of time lag, prediction time lag that is present due to network processing. That was solved with the help of uh, NBITS, neural basis expansion networks, and the accuracy problem was solved with the help of multi-head attention. That is the second. And third is all these forecasting models, time series forecasting models, they require a time series data which is actually having a continuous time series information is required. Now if let's say there are some discontinuities or missing data points in your time series model, then that can be actually replaced with the help of generative networks. So the TimeGAN is a network that you can start with, and if you are having if you are satisfied with the TimeGAN performance, you can use it. Otherwise, if you want to change the TimeGAN network, you can try different combinations of layers that you can use in the generator and discriminator, and you can train it differently, and you can actually achieve better performance based on your requirement. So with that, that is the end of the talk. So if there are any questions, if you want to address any questions, we can also address maybe from the YouTube comments. If there are any questions, we can adapt. So over to the organizers, please. Yeah. I think we have one question, which is how will it be useful for diabetic foot ulcer? Um, so this application is not directly related to foot ulcer as such, but maybe so one way it can help in diabetic foot ulcer is the origin of diabetic foot ulcer is due to it happens due to uncontrolled glucose level, so hyperglycemia, sustained hyperglycemia. So using these models, you can actually achieve better glycemic performance, and hence you can reduce the risk for diabetic foot ulcer. So directly there is no link with diabetic foot ulcer as such. Yeah. Any other questions if there is? Otherwise, we can move on maybe.
Sir? Sir, am I audible? Sir? Sir, am I audible to you? Sir, am I audible to you? Mirza, sir?
Yes, I'm here.
Yes, sir. Yes, sir.
Yeah. I answered this question, the which
Yes, sir. Sir,
comment has.
there are some certain questions in YouTube.
Yeah, we
Can
can
I read
discuss
the
that.
question,
No.
sir?
Yes, please. Yeah, no problem. Go ahead.
I'll just give you sample questions, sir.
Yes. Yeah.
Sir, actually, one of the participants has asked, nowadays we are observing a device which
Yeah.
monitors blood glucose levels continuously. How it is
Yes.
possible, sir, without
Yeah.
testing blood sample?
Yeah. So that is one of the initial slides. We can go back to that. Um, so here, if you look at this particular slide here, so here what happens is, yeah, we can go 1 minute. I think this is the best slide probably. So here we have what we have is we have some. If you look at this layer over here, it is having these are different layers of the skin. So you have the epidermis. Then we within the epidermis we have stratum corneum, and then as you go below the epidermis, we have some capillary networks. Okay. So as we go even further deeper, we have the hypodermis. So generally we are sensing in the dermis region, okay, either in the epidermis or we sometimes sensors go down to the dermis level also. So there these blood vessels actually are having these molecules. So in blood, as you know, there are two components, plasma and blood cells. So plasma has glucose molecules, it has different kinds of other molecules, not only glucose, there are other molecules also. So molecules such as glucose, whose size is smaller than 3 kilodaltons, they actually leak out of the blood vessels and they go out into the interstitial fluid. And this interstitial fluid is being used by the sensors to continuously monitor the glucose level. So if there is any change in the glucose level over here, then that actually is reflected in the interstitial fluid also. But the problem is that there is a diffusion delay. So as the molecules are diffusing from one part to another, there is a delay in diffusing from the blood vessel to outside the blood vessel. So that delay is there. But you can monitor because the ISF or interstitial fluid glucose level is tightly correlated with the blood glucose level. And why it is tightly correlated? It is because the origin of the ISF glucose is from the blood itself. The same glucose molecules are actually leaking out and maintaining the glucose level there over there. Yeah, so that's all, ma'am. Next question, we can move on.
Sir, there is another question from Indian, sir. How
Yeah.
it will be useful for diabetic foot ulcer, sir? Can you please
Yeah,
explain?
that yes. So that I have actually explained. So this model that we have discussed, time series forecasting models, so they are not directly applicable for diabetic foot ulcer. The only way I can think of is you can use these models to maintain good glycemic control, meaning the glucose level is between normal levels, good glycemic control, and by having a good glycemic control, you can reduce your risk of getting diabetic foot ulcer. Otherwise, there is no direct link as such of using these models for diabetic foot ulcer application. Yeah.
Sir,
Yes, ma'am.
Aravind sir has asked another question.
Yeah.
There are two datasets called HAM 10,000 and ISIC. Is there any other datasets, big dataset,
So
which is also
yeah.
metadataset?
So generally in this for the application of diabetes, so I'm not sure what exactly is there in that data set, but for diabetes applications like closed loop diabetes management applications, people generally use, we have actually collected our indigenous data set also. We have also locally, we have with hospital, we have collected. So mostly for the results that I have shown, I have used a standard dataset called as the Ohio Type 1 Diabetes dataset, Ohio T1DM dataset. So this is a standard dataset that is used to benchmark models for this application. So any other paper you see, they have used Ohio T1DM as their benchmarking data set. So Ohio T1DM is one of the good data sets that people have used previously. And so if you are working in this area or you are planning to work in this area, then Ohio T1DM data set is a good one. Second is because it has CGM, continuous glucose monitoring data, as well as your physical activity and meal information and insulin. All of the information is there. So generally, other data sets that are present, they don't have CGM information most of the time. So Ohio T1DM is a good data set. Then there is one more recent data set from Shanghai, I think that also is accessible. You can download for free. Then there is also another data set called T1DEX1, T1DEX-I or T1DEX1. So this is another data set, which is a very large data set with continuous glucose monitoring levels, with insulin information, with for personalized, like they have patients with all these details available, CGM sensing data, they have meal information data, they have physical activity data. So all of this data is required for training and validating the models. So generally when you are actually, let's say you have developed a new model, you have to show your performance against one of these data sets. Either it is Ohio T1DM or T1DEXI, or you have Shanghai. So these are three different applications. So I can write in the comment box, maybe you can also write. So there is Ohio T1DM dataset, and then the other links. So this is a dataset which you can use. Almost all the papers that have that are in this domain of diabetes management, or like time series forecasting, or even insulin dosing, AI based insulin dosing, you will see that they have actually worked on this Ohio T1DM dataset. If let's say for some reason you are not able to access in order to get this T1DM dataset, you need to sign a data usage agreement. That's all. It's free. But in case if you are not able to do it, there is also there is a simulator in which you can generate in silico data. It's called as the UVA Padova T1DM simulator. Okay, so this also you can get. There is one MATLAB version that I think is paid, but people have also come up with a Python version. There is actually a GitHub repository from where you can download a Python version and also generate data initially. That also what we used before we had access to Ohio T1DM. We used to work with that data set. Yeah, that's all.
Last two questions. The first question is, sir, why do we need LSTM when we are already here with RNN?
So there are some problems with RNN. The problem with RNN is the memory problem. RNN is not able to deal with long time series data, like time sequences. So if you have, as a ballpark, I'm saying that if you have more than 100 data points in time and you want to do time series forecasting, then RNN does not perform well. So that is the disadvantage of RNN, and that is what led to the development of LSTM, where people are actually modeling or capturing long-term interdependencies as well as short-term interdependencies. So the problem with RNN is the memory or ability to store long-term dependencies between individual data points in time. Yes, ma'am.
Sir, another question is, in skin cancer classification, which one is good, LSTM or CNN? And for blood vessels, whether it uses ANN or CNN framework?
So this is more of a little bit outside my area of expertise. So you can look at many different papers. So it is mostly image classification. So I haven't worked with any of the data sets where image classification is done. So difficult to comment on that.
Thank you, sir, for spending your valuable time and giving the answers for all the questions where participants have asked.
Thank you, madam.
So it's my privilege to thank our guest, Dr. Mirza Khalid, who has accepted the invitation and has spared his valuable time. His big work in leveraging artificial intelligence for healthcare, especially his leadership in developing advanced machine learning models for accurate blood glucose predictions, has brought a good recognition to NIT Rourkela. His team recent publications in IEEE has driven a digital health forward. We deeply appreciate not only to academic excellence, but also to applying technology for real world impact, sir. And your guidance
Thank
and commitment for these participants were excellent, and the informations were informative, what you have given. And there are good feedbacks in YouTube, sir, where they have told it's an excellent session, informative session, and they have got good ideas from the information what you have passed today.
thank
Thank
you,
you, sir.
ma'am. Thank you very
Thank
much.
you a lot, sir.
Thanks. So with this, I am signing off. Thank you very much.
Thank you, sir. Professional with over 10 years of experience. In her current role as a data analytics custom engineer at Google, she constantly engages with C-level executives and helps them architect data solutions and guides them on best practice to build data and machine learning solutions on Google Cloud. Nivedita has done her master's in technology management with a focus on data analytics from University of Illinois at Urbana-Champaign. She wants to democratize machine learning and AI, breaking down the technical barriers so everyone can be a part of this transformative technology. She shares her knowledge and experience with the developer community by creating tutorials, guides, opinion pieces, and coding demonstrations. We welcome you, ma'am.
Yep, thank you so much. Good morning, everyone. My name is Nivedita Kumari, and I'm a data analytics and AI customer engineer at Google. Today, we are going to dive into a topic that sits at the intersection of two of the most critical fields, generative AI and healthcare. As we have seen rapid acceleration in digital health technologies, from telehealth to medical IoT devices, the amount of like patient data being generated and transmitted has exploded. This makes the challenge of securing this sensitive information more urgent than ever before. So we will explore how generative AI is not only just a tool for creating content, but is also a powerful new defense for medical data security. I just want to make sure like my slides are visible.
Ma'am, it's visible. I think you're on the first slide of generative AI securing
Yeah.
medical data.
Okay.
Are
Yeah.
you moving
Sure.
any slides, ma'am?
Yeah.
Yeah, now yes, ma'am. You're on to second slide.
Okay, awesome. Thank you so much for confirming. So, in the session today, we will begin by exploring the role of AI in healthcare. Then, we will look into some of the challenges in medical data security and how generative AI can be a powerful medical data protection solution. Then, we will also witness a practical generative AI demonstration that shows how we can generate synthetic medical data and cybersecurity scenarios. Finally, we will discuss the ethical considerations and the future of the technology. To start, let's understand what generative AI actually is. It's different from the AI that we might already know, like the kind that recommends movies or recognizes faces. Think of it this way. Traditional AI is a classifier. It analyzes and interprets existing data to make predictions or categorize the information. Versus now, generative AI is a creator. It generates entirely new and original content based on the patterns it has learned from its training data. This capability makes it a powerful tool for tasks like data augmentation, synthetic data generation, and anomaly detection, all of which are critical for medical data security. And we would look later in the slides like how this is really important. Two common types of generative models are large language models or LLMs, which are great for text generation, and generative adversarial networks or GANs, which are often used for creating synthetic images. Now, let's focus on the critical importance of medical data security. Why is it so important to make sure the data is secure? And this isn't a technical challenge. It's a patient safety and public trust issue. So if you look at it, like medical data is a prime target for cyber criminals. And there are like various good reasons why it is. First, it is an identity theft gold mine. Like if you access the medical record, which contains highly personal information like social security numbers, date of birth, their medical health cards or insurance IDs, which are more valuable and permanent than like credit card numbers. Second, healthcare data fetches a high price in the black market, making it a lucrative target for attackers. Third, they target intellectual property like research data and proprietary treatment methods are also like a really valuable asset for corporate espionage. Finally, the ransomware leverage. Holding critical patient data hostage can force healthcare organizations to pay large ransoms to restore services, as we have seen that in the past numerous attacks. A data breach in healthcare can also have like a ripple effect than the effects that we talked about. It extends far beyond the point of the initial incident. It can lead to direct patient harm if if data is corrupted or unavailable, potentially causing misdiagnosis or delayed treatments. The financial costs are also staggering, like provides hefty fines, legal fees, and remediation costs. A breach can also cause severe reputational damage and operational disruption that can cripple hospital systems and impact patient care. To combat these threats, a robust compliance framework is essential. So, adhering to regulations like HIPAA in the US and GDPR in Europe, and this is not just a legal obligation, it's a fundamental part of protecting the patient's data and their privacy. Non-compliance can result in severe financial penalties like legal actions or a significant loss of public trust and damaging the reputation of the firm. If you look at it, at the core, healthcare system is like built on trust. Secure data fosters patients' confidence and encourages open communication, which leads to better health outcomes. A strong security posture reinforces a provider's brand integrity. In a competitive market, robust security measures can be a key competitive advantage. Ultimately, safeguarding patient data is a core ethical responsibility of the healthcare industry. To illustrate the real world impact of these issues, let's take a look at two major data breaches that highlight the consequences that we just discussed. So the Anthem breach in 2015 was a catastrophic event which exposed sensitive data for nearly 79 million customers and employees. The hackers gained access to unauthorized data stored in the database containing name, date of birth, social security numbers, medical IDs, and other personal information. While credit card information was not stolen, the sheer volume of personal identifying information compromised was like a huge disaster. The consequences of this breach were severe. The stolen social security numbers created a massive long-term risk for identity theft. Anthem faced significant financial penalties, paying a record of $16 million civil monetary penalty for HIPAA violations and a separate 115 million US dollars class action settlement. The breach also severely damaged public trust in the company's ability to protect sensitive health information. For millions of affected individuals, the impact lingered for years as they had to continuously monitor their credit card and their financial accounts for any suspicious activity, since SSNs and other details like date of birth were compromised. The second example highlights a slightly different kind of breach. In 2015, Singapore's largest group of healthcare institutions, Sing Health, experienced a severe and targeted cyber attack. The attackers actually gained access to the personal data of 1.5 million patients. And what makes this breach particularly significant is the data that was compromised. The attackers actually specifically targeted the outpatient medication information for over 160,000 patients. The explicit targeting of medication data, especially for high-profile individuals, suggested motives beyond the simple financial gain. The disastrous consequences were widespread. The incident caused significant public fear and anger in Singapore. It led to a comprehensive review of Singapore's public sector cybersecurity practices, resulting in new policies and a temporary internet segregation for public sector computers. The attack also severely impacted the reputation of Sing Health and the broader Singapore's public healthcare system regarding the ability to protect the sensitive patient information. So through these two examples, we can think of the extent, the damage it can do if we do not make sure the medical data is secured. So now that we talked about different ways the medical data could be hampered or tampered with, Now let's turn our attention to the solution piece. How we can secure that and how we can actually secure the data with the help of generative AI. Generative AI provides a transformative set of capabilities for securing medical data. It enables enhanced data anonymization by creating synthetic patient data for research without compromising on privacy. It excels at advanced anomaly detection, identifying unusual patterns that could signal a breach. It can also facilitate secure data sharing by allowing controlled access to sensitive information. And it also provides predictive security analytics measures to anticipate and mitigate threats. A key challenge for security teams is information overload. Generative AI can actually analyze vast, unstructured data from the web and other sources to identify emerging attack methods, like what are the new trending attack methods and how can we prevent those attacks. It can then generate like predictive threat reports in simple language along security teams to prepare in advance. For example, an AI could analyze a new ransomware strain and predict how it might behave within a hospital's network, identifying vulnerable systems before an attack occurs. This is like a crucial use case as well. Researchers need a large and realistic medical data sets to train AI models. But if you think real patient data has significant privacy risks, generative AI can create synthetic medical data that is statistically identical to the real world data, but it would contain no identifiable information. So this fictional data can be used safely for research and testing, solving the data scarcity problem without compromising on single patient's privacy. A breach can happen in like milliseconds, and human reaction time would be like is often too slow to that. So that's where like AI agents come in. They can be deployed as autonomous guardians that continuously monitor data traffic and access patterns. If they detect a threat, they can take immediate automated action, like isolating a compromised device or by blocking a malicious IP address. And this all could happen within like milliseconds. So this moves security from human in the loop response to a more automated and real-time defense. Generative AI also excels in learning normal patterns within vast medical data sets. So this actually allows you to identify subtle, unusual deviations that could indicate a data breach or an unauthorized access or a malicious activity. By flagging these anomalies in real time, it acts as an early warning system. It enables a rapid response to threats and minimizing the potential damage to sensitive medical information. Generative AI can also facilitate secure and controlled access to sensitive medical information for collaborative research, which is really important. For research, you want to like collaborate with other experts in your field and you want to share your results or your data with them. But then how do you do it in a secure fashion? By generating anonymized and synthetic data set, it enables multiple parties to share and analyze data without directly exposing protected health information. Fosters innovation and breakthroughs while strictly adhering to privacy regulations. One last thing, we can also use generative AI to proactively test our defenses by simulating sophisticated cyber threat scenarios. And this is like really crucial in making sure your system is ready. This includes crafting realistic phishing emails, generating novel malware code, or creating convincing social engineering scenarios. This allows organizations to identify vulnerabilities and train their staff in a safe, controlled environment, leading to a more resilient security posture. So, through all the different ways like AI can help protect data, the future of AI in data protection is really bright, and it helps you to like shift from a reactive to a proactive security model. AI can will enable like dynamic security protocols that adapt to emerging threats in real time. This will lead to more robust, resilient, and intelligent defense systems, ensuring the confidentiality and integrity of medical data. We talked about like different types of threats and how AI can help. So now let's like take a look at two live examples of these concepts. So in the first use case, like one of the problems is that researchers need large data sets, but real patient data has privacy risks. The solution is to use generative AI to create synthetic data with similar statistical properties as the real world data, but it's completely fictional. So this offers major benefits like privacy, as there is no exposure to real patient data. Scalability, as you can generate millions of records on demand, and accessibility, as it enables research with previously inaccessible data, which wasn't available before. So for the demo purpose, I am using BigQuery ML within BigQuery. So BigQuery is a fully managed serverless data warehouse that enables scalable analysis over petabytes of data using SQL. And BQML is a feature within BigQuery that allows users to create and execute machine learning models using SQL queries. So the first step would be to create a BQML model that connects to Gemini endpoints. And this will allow like data professionals or anybody who's trying to build these models and use it to secure their environment, and they can like build these advanced AI capabilities directly within with SQL and without learning like a new language, or they can use Python. So the first step, we created a model. Now we would use that model to generate synthetic patient data. For that, here I am leveraging the ml.generate underscore text. This is the out of the box function that I am leveraging. It's really simple to use it. Like you have the function and then you give the prompt, you define certain parameters, and I'm asking the model to generate 10 patient records in a JSON format. So if I read through the prompt, the data should be entirely fictional and should not contain any information. The data that I want it to generate should have certain fields like patient ID, patient name, age, gender, their diagnosis, and their blood pressure. And within like few seconds, we'll have the synthetic data generated, and you can expand it to like generate millions of records. So this is the output that I received. So as you can see, the output is a perfectly formatted JSON object. It is structured exactly as we instructed the model in the prompt. If you look at a single patient record to see what was generated, for example, let's look at the first example generated. And I also highlighted that in bold and with a yellow background. Alice Johnson. You can see that the model created a fictional patient ID for her, along with the patient name, age, gender, and specific medical details like diagnosis of blood pressure and then the blood pressure of like 140 by 90. The key here is that All of this data is completely fictional and contains no real personal information. The model has simply learned the statistical relationship between these fields and generated realistic looking but entirely fake data. For instance, if you look at the second highlighted patient record, it knows that a 70-year-old person is more likely to have a diagnosis like coronary artery disease, and it has generated the corresponding blood pressure reading of 135 as well. So this output directly addresses the problem we identified earlier. So we know how we now have like realistic data that is privacy safe, that is scalable. We can generate billions of records on demand and accessible for research and model training. This is the power of generative AI in action. So solving the data scarcity problem without ever compromising on single patient's privacy. Now, let's look at the second example, and I find it really interesting. So, we can use generative AI to create cybersecurity threat scenarios. The benefit is that it empowers security teams to train their staff and test defenses against realistic evolving threats, but in a safe and a controlled environment. The proactive approach helps to identify vulnerabilities before a malicious actor can exploit them or enhancing the overall security posture. Similar to the last demo, I'm using BQML model to connect to Gemini endpoint and create a model here. Now, here in the prompt, I have tailored the prompt, but we still use the out of the box function. And in the prompt, I am directing the model to generate synthetic two cybersecurity scenarios in a JSON format, and the data should be entirely fictional and not contain any real person information. And I want the detailed scenario to be included. And we are asking for two fields in the JSON, scenario ID and scenario as an output. So as I move to the next slide, you'll see we got two scenarios generated with scenario ID and a detailed description. The real key takeaway here is the model's ability to generate complex and realistic narratives on demand, which is really valuable for security trainings and making sure the medical data is secure. Let's look down at the first scenario. So if you look at the first scenario, which is a classic example of social engineering and spear phishing, this attack is meticulously crafted to mimic an internal HR communication regarding a mandatory security update. The email contains a malicious link that downloads a Trojanized installer disguised as a VPN client. A fictional senior system administrator, Elias Vance, inadvertently executes the malware, which gives the attackers a persistent backdoor. Now, if you look at the second scenario, which is completely different from the attack mentioned in the first one. This one features a novel ransomware variant called ShadowLog, which exploits a critical vulnerability in an unpatched IoT device. The device, a smart HVAC controller, provides a pivot point into the broader corporate network. So the ransomware then rapidly propagates, encrypting critical research and development data, clinical trial results, and manufacturing control systems. So the attackers demand a large ransomware in cryptocurrency to prevent the data from being permanently deleted or publicly released. So as you can see, the model generates complex and varied threats, various types of threats, from a targeted phishing email to a ransomware attack on an IoT device. And these are not simple generic attacks. So they include fictional details, plausible attack chains. So this capability allows you to move beyond the basic security training and proactively test your defenses against the evolving realistic new threats coming up. So moving beyond like simple data generation and the examples that we look at, let's talk about how can agents help here. AI agents are autonomous, goal-oriented programs. They can act independently and interact with systems. While generative AI creates content, AI agents use AI to perform complex actions and act as a data guardian. So there are different ways agents can help. I have like 3 use cases listed down here. So the first is real-time threat detection. They can continuously monitor for unusual patterns and take automated actions. For proactive compliance support, agents can build automate auditing, access control, and data redaction, ensuring that every action aligns with regulations that has been set up by your company or by regulations like HIPAA. Finally, to secure the generative AI pipeline, an agent can act as a secure intermediary, stripping out sensitive data from a query before it reaches a public model, or is reintegrating the sensitive data securely on the output side. So let's look at like how this whole agent ecosystem works. Here I have one example when kind of an architecture diagram that talks about like a visual representation. So this shows how AI agents can create a multi-layered defense system that actively protects medical data. Think of it as an autonomous specialized guardians working together to secure our most critical asset, patient information. So at the center, you see the medical data repository. This is the core of our ecosystem. The sensitive, protected health information that we are here to defend. Everything else in this diagram is built to protect this center core. So let's go around in the circle and look at like each agent's role. So on the left, we have like data anonymization agent. It's after that we have access control agents. These are multiple of these because access controls are dynamic and granular. These agents ensure that only authorized personnel or systems have access to specific data. And they can be based on a user's role or a task that they are performing. And this is like really crucial for maintaining compliance. Then we have threat detection agent, which is constantly monitoring the network. It's not just looking for known issues, it's using AI to learn what normal data access and user behavior looks like. So this allows it to identify and flag subtle anomalies that that a human might miss, acting like an early warning system for a potential data breach. Below that, we have the compliance monitoring agent, which works tirelessly to like audit all the data activity. It automatically generates detailed logs and reports, ensuring every action aligns with regulations like HIPAA, which is essential for legal and like financial protection. Then we also have incident response agent. Uh, if a threat is detected, this agent can take immediate automated action, like isolating a compromised device or blocking a suspicious IP address, and this all could be done like within milliseconds to minimize the damage before a human can actually react to it. So in short, like this is how we move from a static reactive security model to a more dynamic and proactive intelligent defense system that can safeguard the medical data in real time. So generative AI, we all looked at like it's such a powerful tool for innovation. When it can protect, while it can like protect the medical data, it also like presents certain risks. So one of the biggest risk is a bias amplification. AI models can learn from data they are trained on, and if the data contains historical biases, the model can perpetuate and even amplify them. In healthcare, this could lead to outcomes and like misoutcomes or misdiagnosis of underrepresented patients groups. Another major concern is misinformation. Generative AI can create convincing but fake information, such as fraudulent clinical notes and misleading research findings, so which can have like serious consequences in a medical setting. So to navigate these challenges, we must follow two key areas: responsible AI and collaboration. Responsible AI practices involve implementing advanced governance, ensuring transparency in how models are built, and maintaining human oversight to catch any potential issues. Ultimately, AI should be viewed as a tool to augment human expertise. By blending this powerful technology with human judgment, can lead to a more secure and ethical future for medical data. To summarize, the key takeaways are: AI enables enhanced data anonymization and anomaly detection. Generative AI secures medical data against cyber threats. We can use proactive threat simulation to strengthen our security measures. And all of this must be done with a focus on ethical AI use to ensure responsible data handling, which is like really important. With that, I've come to the end of my presentation, and I'm opening the floor. Like if there are any questions, we can take that.